This is how it should start. Boom. All right, cool. So we're all web developers now, right? You come here to learn about software engineering and web development. What is the internet? This is like a non-rhetorical question. All right, just get a little used to my style and my flavor here. I'm ridiculous, but I also ask like non-rhetorical questions. So if you just want to help me out, help you. What is the internet, or what do you think the internet is? Or if you could describe the internet, how would you describe it? And it's not just memes, even though it's basically what it is. Yes, sir.
In super simple terms, it's just a bunch of connections between computers.
A bunch of what now?
Connections.
Connections?
Yeah, like a giant web.
Okay. I see where you're going there. Maybe this web is worldwide? Possibly. Cool. Anyone else? Okay, great. I'll just tell you then. No big deal. Sweet. So the internet, actually, believe it or not, is all just wires, right? All the internet, the entire world, you are absolutely correct. It's all just wires. We're all connected through these wires, and the wires send information back and forth, all the data that you could possibly imagine in the entire world, right? So how is it that like this computer here, which is hooked up to this HDMI and this mouse, is getting internet wirelessly? What is happening here? Yes, sir.
The routers are propagating a signal that allows response requests to happen between your computer and ultimately the cable.
Absolutely, right? So what it really is the internet, right? If you could just imagine this like giant wire running globally that spider webs, all right, to like every single house, every single country, all across the world, even across the ocean. And it's just sharing data. And that's all it is. So like think of like back in the day, right? Like back in the day, not like you were alive back then. And if you were, we have a lot to talk about. But this gentleman by the name of like Alexander Graham Bell like ran a line to somebody else's house and just decided to like pick up and started talking. And then that wire transmitted like the voice. Does that make sense? Am I like making stuff up here? No? Sound familiar to you at all? Slight history lesson, right? Except instead of just voice, imagine all the memes, right? All the jokes, all the Googles is sending data back and forth between those two phone lines. And that's really essentially what's happening. So I'm going to try to break that down for you in something that's like a little bit more sensible. Cool? Oops, just kidding. All right. So back in the day, right, in about 1969, Stanford, here we go, let's go a little bit of this, right, Stanford over here, Stan, right, decided to connect to another, oh man, this is painful, sorry, decided to connect to like another computer, right, in UCLA, because computers existed before the World Wide Web existed. Does that make sense? Right, there was like these computers that housed information on a hard drive that could do computations, can run very, very simple applications, and they tried to connect them through wires in the same way that the telephone line worked, and they wanted to just transmit data back and forth to a computer. So the first thing they wanted to send in, naturally, was this word called login, right? L-O-G-I-N. They actually got it up and running. They established a connection between the two computers through a long running wire between like Stanford and UCLA. Bloop. So like here to here. It's kind of long actually. You know, like not drawn to scale, right? And what they wound up sending was L, and then O, and then it crashed like a champ. So whose Mod 1 presentation went off like perfectly? Yep, sounds about right. Congratulations, welcome to the world of presentations. It will always go like this, right? You're gonna run it on your server, you're gonna run on your computer, and everything's gonna run perfect. And then you're gonna get up there, and you're gonna be like, yo, I can't wait to show you this. And then immediately it's gonna be like undefined method error. You're like, okay. All right, let me just quick debug real quick. All right, everything is like busted thanks to like original sin over here. So the first transmission, the first presentation, went Ari, and we're cursed forever. So thanks. But that's basically what wound up happening, right? That's like the beginning of the connection of different computers, just inter-computer connections. Any questions so far? Yeah, it wasn't very complicated. I hope not, because it gets harder. Yeah? Cool. All right, so back to the internet. Boop, 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 boop. All right. There's a gentleman by the name of Vinton Cerf. You don't have to write any of this down. This is just like history, right? V-I-N-T-O-N. Cerf spelled C-E-R-F. And this is the person that invented something called TCP. Does anyone know what TCP stands for? Just cool. What was it?
Is it, I'm just guessing, words, transfer something protocol?
Pretty good. Wild guess, actually. Strangely accurate. Does anyone, like, who's a CS person in here? There's a couple CS people in here. Okay? You're just, like, faking the funk right now? Okay, very good. All right, well, in that case, correct me if I'm wrong, right? So, Vinton Cerf, right, invented something called TCP, the Transmission Control Protocol. And all it is it is the established way that we send data back and forth, right? So you heard of something called like HTTP? What is that? Something, just protocol, right? Yeah, and the sorcerer's stone, very good. Yeah, so it's just hypertext transfer protocol. So all that means is, what is hypertext?
It's like a markup language, no?
Exactly, right? Remember, I don't know, hypertext markup language? HTML? Does that look familiar to you? So imagine I could send just text back and forth through computers, right? And in each computer, I had some sort of application that could read this text and transform it into something else, right? And so essentially, that's like what's happening, right? In the hypertext transfer protocol, I'm sending you, right, like a div, like a p tag, right? I'm going to send you something wild, my mouse, right? I'm going to send you something like this, right? I'm just going to send you a bunch of strings, and then your browser is going to interpret what this is, and it's going to just render something cool on the page, right? So like, let's just say, for example, I don't know, I just Googled ARPANET because I didn't memorize it, right? And I wanted to see, have you seen this before? The inspector, what does it do? Okay, very good. Yep. And Google Googles. Nice. All right. I'm going to inspect the HTML and the CSS that's on my page. So here, all I see is a bunch of these divs, right? A little H2 action, right? And they're all just like sort of nested. I can click this button, and I can see which of these elements everything is, right? So like this Google image is just coming in from this image tag right here, and this is the source that it comes from. So if I can send you all of this string, your browser, right, whether it be popular ones like Netscape Navigator, right, Internet Explorer, what have you, Opera, Dolphin, all the good ones, know exactly what to do with this hypertext markup language, right? In the same way that if I wanted to, I can just do this and see, I don't know, all. Instead of all, I can change this to, I don't know, ya boy, right? And there it is, ya boy. Boom. It doesn't save, it doesn't persist, right? So don't think you're like hacking the internet right now. But that's all it's doing, right? If I can send all of this over, my browser knows how to interpret it and render something cool and sexy, something that I would recognize, right? Like if I just looked through this, and I was like, oh great, this is Google, fantastic, cool. Let me go through all the searches here, let me look at this information, like you'd be like, lose your mind, right? This is not really too human readable, as opposed to what's being rendered and displayed over here. That make sense? Okay, so back to our boy Vinton Cerf, right? TCP. Have you ever heard the phrase TCP followed by any other letters?
IP.
Yes, IP. What is IP?
Internet protocol.
Very good. All right, what is Internet Protocol? All these protocols, right? What does this mean?
Like an address?
Hmm?
Like an IP address?
Oh, like an IP address. Very good. Nice. Like came out of nowhere. I couldn't see. My vision's bad. So like an IP address, right? So if I have something called TCP/IP, what can I do with this information? If TCP controls the way I send data, right? And the IP is essentially like what? What is IP here?
So it's like the address controls who you send the data to and then who sends the data back to you.
Nice, right? So if TCP, right, is like how I'm sending data, algorithmically in a protocol, I'm gonna break down data a very specific way, right? And then IP is what? IP address, you've heard this phrase before, is what? Is like your local machine, whether it be your laptop, your desktop, like PC Master Race, whatever, or your phone. Then I know how to send the data, what the data is, to where. So like, does TCP IP sort of like gel a little bit more in your brain? You don't have to break it down to like the craziest level, but we will, right? Boop, 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 right? So what is, all right, TCP IP? What is this, right? Boop, boop, boop. Let's check Wikipedia, the most reliable source on the internet. Cool. Here, we can see, right, there are different layers to what is happening inside your protocol, right? What you really need to know is all of this breaks down to, okay, just kidding. This is not really important right now. This is like really, really comp sci stuff, and it's cool to Google and look into, but what you really want to know is, hey, where are the packets at, man? Packets. I'll just do this. Packets. Here we go. Boom. Oh, Vint and Surf. Here we go. Vint and G-Surf, a protocol for packet network intercommunication. Inside, right, all of these requests, all of these like page loads, all of these things, inside your TCP, inside your layers, are something known as packets, right? All of this data that I was talking about earlier, over here, gets broken down into binary, right? Like all of this eventually gets broken down into like hundreds of thousands and millions of like ones and zeros. Does that make sense? Because the computer doesn't need to understand div. That's something we kind of need to understand as more like human readable version. Because it breaks down to these bits, these ones and zeros, it's the smallest bit of data you can possibly imagine. And what we do is we take all these bits and we send them through these wires, right? Okay, sorry. We send them to these wires over here. They literally travel at the speed of light. I don't say literally very often. So when I do, like I actually mean it. And it just travels through these wires at the speed of light. So when I go to a website, I get a response within a couple of seconds, which if you know the speed of light, that's actually relatively slow because it has to make so many of these requests, right? I'm going to go to a particular IP address like Google, and then what happens? Google sends me back something. I'm going to go to, right, like a very cool website, right? I probably shouldn't go here, but it's fine. Risk it. Okay, cool, safe today, right? What happened just now?
You typed in the address for the home site, and it rendered the index page to you.
Okay, right, using like interesting words there, like index. Okay, so what I really did was I went to something known as like the URL. Does everyone know what that stands for? What is it?
I know what it is.
Uniform resource locator.
Okay, a lot of good guesses here. All right. Uniform resource locator, all right? And that stands for something, right? Words mean things. So what would uniform sort of mean in the idea that I want everything to be the same, right?
Standardized.
I want to standardize something, right? What would resource indicate here? What is like a resource to you? Like I need more resources or there are not enough resources. What is that?
Pictures and words.
Huh?
Pictures and words.
Sure, memes, right? Just all memes. The spiciest meme lord. No. Resource just like things, right? Like I need more things to do whatever. Whether it means like fossil fuels for like gas or water from a plant, that's like a resource, right? And what would locator indicate? Do I know where it is if I need a locator? Well, if you had a locator, right, and you're using it, do you know where whatever it is that you're looking for is? You ever pull out Google Maps and be like, I definitely know where it is, but I'm going to look it up anyway? Like, no, it's like 2 blocks right there. I could see the Uniqlo like flag down the block. I don't need to pull out Google Maps, right? So the locator just indicates that it's something you don't really know where it is. So if I have a standardized way of looking something up I don't know, and I tell it what it is that I'm looking for, the resource, that would be pretty useful, right? So like URL should have some sort of meaning to you now, right? So let's talk a little bit about like the URL here. When I go to reddit.com, right? I don't think I don't have a book face. So should like do this. I know. I'm a loser. 0 friends. 1 star. So what happens when I go to Facebook? What happens when I go to bookface.com? All right. You mentioned something about like a get. What does that mean? Like if I have like a get. Okay, I'll just tell you that, right? Yeah. Yes.
Is it that Chrome, your client, is making the request? Is it to the Facebook server, or is it something that holds Facebook's info and then giving it back to you?
That's exactly correct, right? So I'm going to give you what I would describe as like the jankiest internet demo ever, right? Cool. That's actually, I gotta find it. I think it's in my notes. Boop, boop, boop. All right, ready? Let's see. Flatiron School. Where's my lecture notes? Cool. Ready? Let's talk about router. Let's talk about email, right? Cool.
Did you print that out and do that yourself?
Maybe. Maybe, right? Don't worry, I'm gonna walk you through this, right? So, cool. All right, which one should we start with first? Let's start with this one, right? Let's start with a little email action. Cool. Everyone see this? Simple. So this black wire, right? I know. Just look at this. But this is hip. AOL is actually worth a lot of money. They're still around. Anyways, so this black wire, right? Think of this black wire as the internet, right? Are you directly connected to the internet? Are you directly connected to, not you, right? We're not like Avatar, we like take our hair, plug it into the trees. I'm talking about, oh, you got the reference? Wow, I'm not that old. Very good. A lot of these just fall on their face, right? So this black wire is the internet. Who has moved ever in their entire life, ever before? Ever. Moved, right? Like, you like no longer lived at your current residence and you live somewhere else, right? In case you need the definition. So, who remembers going to this new house, going to this new apartment, and being like, oh, I gotta call Cox. I gotta call Spectrum Wireless, excuse me, and I need internet. Do you remember this experience? Right? And they're like, hey man, no big deal. I got you, fam. I will be there next Tuesday between the hours of 8:30 and 6 p.m. So please take off work. Great. I'll be there. Great experience, right? What is that company? What do we call a company like that? Right, the ISP, right? What does that even mean though? So if we don't have access to the internet, we need somebody to give us access to the internet. Does that make sense? So lo and behold, the internet service provider. Does these words make sense to you now? All right, cool. It's not like, oh, I'm just gonna call Spectrum, like, oh, they're my ISP. I just say these letters, I have no idea what they mean. I'm just gonna guess at what they mean later for funsies. But yeah, it's just ISP. So I need to connect to the internet through like Time Warner Cable. I'm old, sorry. I also call it the Queensboro Bridge, 59th Street Bridge. What do they call it now? RFK? Joke. Anyways. So me, client, right? So you're the client now, right? The client is anyone that is making the request. So far, so good? Okay, so you're the client, and you're now connected to the ISP at $79 a month. Great deal, I guess. And I want to send, right, Aunt Ruth an email. I'm like, yo, just checking in, NBD, how's everything? Sorry, I can't make it to your birthday. Thanks for the $100, right? Because I'm like a good nephew. That's what good nephews do, right? So I'm going to send an email. On my client, I'm going to go to Gmail because I'm hip and I'm with it, I guess. So I go to my client, right? I connect through my ISP, right? And we're going to talk about router here in a little bit. But when they came over to your house, what did they have to do? Why can I not use Verizon, Spectrum, Cox, and all the other internet service providers? I'm locked down to how many? Sounds like a monopoly, but we're not going to get into that, right? That's not today. That's more politics. You're only allowed one, which is, I have a lot of opinions on that. So, you're only allowed one, right? And Spectrum's like, great, I'm going to come over at a very convenient time, and I'm going to set up the internet for you. They literally ran a wire from the street into your house, right? And you know this because what did you connect your router to? Like a port on the wall? That wall port connects right outside. If you look outside your apartment, you're like standing outside your apartment, you can see wires coming out of it. Those wires are connected ultimately all the way back to the ISP HQ, which has a line into the internet, right? That giant wire. Is that all starting to make sense now? That's how it gets fed into your house. And so here, I'm going to go connect to the ISP through the router, through the line, through my wall, and I'm going to go to Gmail. I'm going to make a request to the Gmail server, and I'm going to say, hey, I want to access my email. So I go to my client, right? I open up Chrome, I go to gmail.com, and then now I'm through my ISP. I'm here in the internet. The internet tells me to go here. This is where the Gmail server are. All right, look at this drawing. So good. All right, if you look really closely, they're like cut out. You know what I'm saying? So I can't draw. So I'm in this Gmail server, right? What is it going to do? It's going to process my email. When I hit send, right, I told it to do something. I sent it information. I sent it parameters of which I want the head, the subject, and the body of my email to be. And then it did something with that. The server did something with my parameters, like, hey, listen, Aunt Ruth at AOL.com, right? Subject, your boy, and then like body, miss you, love, Wangtron, right? Something simple, normal email traffic. What does Gmail do from there? As the server, it will do something, and that is it sends it back to the internet. It goes across this wire here, wherever that may be, over to AOL.com, because Aunt Ruth is like in the future, and she's still using AOL. Here, the wires that I told you about are literally going into her house on her laptop, which is probably like a Dell Inspiron from like 97. She logs in and connects back to the AOL server through her ISP, right, and gets that data. And now she opens the email, and she's like, oh, wow, my nephew's so great. He emailed me. Stud. Right? Any questions on, like, connecting to the internet, sending, like, a request, and how it kind of routes, sort of, like, conceptually? All right? It's all pretty simple. All right? Just a bunch of wires. I'm sending data through wires. Okay. Now, let's just get to a little more complicated example. Cool. Let's check out like the router thing here, right? Let's just say you're at a school and all of you are trying to connect to the internet and it didn't work, right? Like, no, too soon? Okay. We are all on this router, right? We're all assigned an IP address to identify each one of us uniquely. So that if I'm over here like pretending to work really hard and I'm over here like tweeting up a storm, and you're like, wow, Evans is so busy, I probably don't want to ask him any questions on like Rails. All right, I'm over here like, ha 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 ha, retweet please. You know, like smash that like button, that subscribe button, notification bell squad, where you at? No, I'm trying to be relatable. I'm not as young as I look. So, I have a different IP address, right? So, I'm sorry, these graphics didn't come out so well, but it's fine, you'll see them. 192.168.1.10, and then here for my boss, it's coming in at 1.11, right? Just a little bit different, right? Each kind of different. And the way I want you to think of this, like analogously, is, all right, kind of on the older side, but who remembers like memorizing friends' phone numbers? Do you remember this back in the 90s? Oh my God. Okay, great. Sorry. The last two classes I had, like the average age was like 23, 24. So I would talk about like Netscape Navigator, and they'd be like, and I'm like, you remember the CDs? Like, hey, you got like 3,000 hours of online? Okay, great. Awesome. This class is funny. Oh, yeah, that's right. Remember that? Oh, no, the toaster's going to attack me. Oh. Anyways. Wow. Anyways. So, IP addresses, right? Sorry about that. We all have our own unique IP addresses that is issued to us by our router, right? So if you remember phone numbers, right? Who remembers phone numbers now? No, stop playing. You don't do that. You don't do that. All right, besides mom or like bae, like you don't remember anyone's phone number. Let's be real. I had like at least 9 in my head, and now it's all just 8675309. You know, I'm calling Jenny. So, okay, that was actually pretty good. Good response. Good job, team. It's a really old song. Anyways, these IP addresses, right? They're essentially phone numbers, right? When you call somebody now, right? If you're like open up your phone, right? I have one of these, by the way. It's very cool. And I call somebody. What displays when I call them? Is it the phone number or is it just the name? Just the name, right? Like Boothang comes up, right? Doesn't have all the digits anymore. So that's what we did, right? We kind of transferred over from this IP address system into something more human readable. But we needed to tell everybody, this is how everyone's going to do it. So we had to create some sort of uniform standard to find everyone's IP address, like some sort of locator for a resource. Right? Cool. So now URL essentially just stands for, right, Uniform Resource Locator, but what it really is my computer, when I tell my browser to go to google.com, it's actually going to hit something called the DNS. And the DNS server tells me that when I put in Google, this is the actual IP address for it. So let me show you an example, right? Boop, boop, boop. Let's zoom out of this bad boy. I think we have network utility. Cool, right? So I can go to Bookface, right? I can do, you have all this, right? The Mac is just called network utility. It'll start at info. Go to trace route. You type in like a cool website. You hit trace. You can stop it immediately. It's fine. This says, cool, I go to Facebook. This is the IP address for Facebook. When's the last time you were like, yo, let me log into Facebook real quick. 31.137136. Got you, fam. All right? Probably not. But if I wanted to, I can go right to this IP address here. I think it's like port 80, right? It's the default. And it should take me to Bookface. Right? Right? So that's essentially what's happening. So back to this, right? I have my IP address that's identified as you. Or we can have boss, right? Cool. Boss here. It's going to hit my router, right? Because we're all connected to like the Flatiron School router, right? So if I'm trying to go to Bookface and my boss doing his or her due diligence wants to go to marketresearch.com, whatever that is. I just had to think of something like generic and corporate-y. It's probably Brandon making fun of me. He can hear me like outside this thing. So it hits this router, right? When I hit the ISP, right? When Brandon and I, right, my boss and I, we go to the internet. How does the internet know which one I get sent to and which one he gets sent to and who gets a response from where? My IP address identifies me. The router however, is going to route individual requests to the correct place. So it assigns me an IP address that identifies me. It's saying, oh, hey, 192.168.1.10, you want to go to bookface.com. Roger, you're requesting this information from Facebook. Cool? And my boss, right, 1.11, is going to request information from marketresearch.com. So it hits the router, it separates those requests, right, because they're all hitting the router. They're like, great, 1.10 is going to Bookface, 1.11 is going to Market Research. It sends that data to the ISP, it hits another router inside the internet, right? It's just like a machine that separates. It's going to figure out, right, what is Facebook.com's IP address? Oh, it's, well, it changes all the time, right? But in this example, it's interesting numbers that I probably don't want to say out loud, right? First one's intense. And it's going to get me that information. It hits Facebook's server. That server understands this request and goes, okay, great. Let me send you back the login page because you're not logged in. So then it comes back to this router, hits this, and goes, wait, where did this come from? Oh, this came from ISP over at Flatiron School. Let me send it there. And then this one goes, wait, where did this come from? Oh, this came from 1.10, and it sends it back to me. So in all of those layers of TCP, it holds a little bit of data about where it's coming from and what information that I want. And then it sends me back that information from the server. So far, so good? Cool. Any questions on like how this kind of internet works, the IP address, uniform resource locator, and GET requests? Your hand first, yes, sir.
So a router always belongs to someone, right? Does that red one belong to an ISP?
Yeah, you could say that.
Okay.
Yeah, the router will always basically belong to somebody. There's no like,
Just out there to like be out there to help you.
yes, it routes the information based on the information it gets in the different layers of this TCP, right? In this request, in this protocol that we send all the time. Cool?
Okay, so I know that HTTP and HTTPS are like pretty similar, except HTTPS is more secure. And how come when you log into a website, like I know that definitely Facebook and Google are HTTPS, how come it doesn't always show it and you can just write HTTP for short?
Okay. That is beyond the scope of this lecture, and that is a much, much deeper dive into security. And I will touch base with you offline, and I'll send you some resources out to the class about like HTTP and HTTPS. But they are, they're a lot for right now. This is the intro to the internet. That would be like Internet 401.
I was just curious.
Too easy.
This point, so for example, you said for Facebook, their default port number is 80,
Mhm.
and like on your local machine, it's like 80, 82.
Yeah, absolutely. So 80 is the default for the World Wide Web and the internet in general. So like any IP address I tack on, if I wanted to go to Google, Gmail, GitHub, I could tack on .80. And that is the default port because that is what we've all agreed to uniformly. All right. I can spin up different servers, and we're going to touch base on that here in a little bit, on different ports that run different instances of my server, and that will make more sense later, I promise. So just have an idea, something like that, right?
Can you just reiterate through the layers of the internet again? You just mentioned.
Yeah, I just mentioned them. I glazed over them. That is like really into like CS, and if you want to read into it, the different layers, I'll send you some resources for it. But what you really need to know is that in each individual layer, it kind of holds information about where the request is coming from, all right, where the request is going, what information you want, and like the data, right, the packets. So it can get really long. I could talk for like 3 or 4 hours on it, but we don't have that kind of time. Let's get coding.
Is an IP address always the same, or it depends on like what router you're hitting? Or like
It depends on the router you're hitting. Yeah. So you will be assigned a new IP address every time you connect to a router. And that will be your particular IP address for that session that you are logged into the router. Because once you log off the router, a new person is probably going to log in, and they want to be able to reuse that number at some point. Cool? Cool. All right. So you're probably wondering, like, all right, we're web developers, all right? What is like the biggest threat to the internet right now? Is it global warming?
Sharks.
Is it politics? Yes, it's sharks. Sharks are the biggest threat to the internet right now. Here, let me just take a quick commercial break from what's going on. And this essentially, all right, check it out. Ready? So sharks, for whatever reason, we have no idea why,
Actual sharks.
they legitimately just get pissed off by these things. This is the wire that I was talking about earlier. It just bites it. It's just like, man, that looks tasty. And then it just goes away, and it's like, that was weird. Huh.
I mean, someone provided the micro text. I kind of sympathize.
You're right. Sharks are very territorial. They're like, yo, what's this wire doing here? Just attacks it, you know? You gotta let these things know what time it is sometimes. You know what I mean? So, yeah, that's like the biggest threat to the internet right now, like sharks. So we are constantly running new cable because sometimes they get through, you know? All right, so like let's break down a little bit of like the density of this wire. All right, it's like 17 millimeters of like density. It's some copper tubing, steel, and then ultimately some petroleum jelly. Right answer. You gotta make sure it's petroed up. And then there's these like optical fibers that like actually send the data back and forth. Cool? Questions on this? So like here, look at Batman taking care of business over here, saving the freaking internet like a champ. What a G. Thanks, Batman. You ever see this movie?
Yeah.
Okay, great. I'm in the right crowd. Cool. I'll watch this movie. It's so good. It's Adam West, yes. If you don't know who Adam West is, he's the mayor in Family Guy. Same guy. Same guy. Huh? Oh, yeah. So we talk about like request and response. This is like the student-facing README that I'm going to upload. I'm just going to go over a couple things, right? When I talk about HTTPS and HTTP a little bit, about like the protocol in which like data is sort of transferred, I keep talking about something called GET, like you're getting information, right? So who runs the internet in regards to defining the docs, right? You know, like when you talk about Ruby, like, oh great, I'll just go to the Ruby docs. Where are the internet docs? If I were just to be like internet docs, like what would like happen? No, good guess though. They talk a lot about HTML and stuff, right? Right? The MDN is the Mozilla Developer Network. These are the folks that do the web docs, right? So if you like Chrome and you're like, ooh, Firefox sucks, so they're kind of like in charge of Firefox. No big deal. Cool. So here is the docs forum, and they're really good, right? When I said earlier about like sending information and getting information, right? All I'm doing is, in Google, I went to google.com, right? I asked for information. That was a GET request to Google. I'm asking Google for information. So in Google server, they sent me back what? Just like the Google regular search page, right? In that search page, what did I search for just now? I put in Mozilla Developer Network. I sent information over. I sent these parameters in which to search for something. Does that make sense? In the world of the internet, we call this a post request. Whenever there's some sort of form, whenever there's some sort of search bar, whenever there's any input from the user going to a server, this is going to be a post request. Any questions on that? So like get and post, there's like a difference, yeah? So I'm going to send a post request to Google, and when I do, I get a new page, new HTML that is rendered dynamically. I will then click this link, and this link, am I sending information when I click this link? Am I like sending user input? Like, hey, I'm typing something in, and I'm sending something in a form. So what kind of request would this be? Get or post? Cool. So that's a GET request, right? So I sent a request to the Mozilla Developer Network, right, the MDN, and that server gave me back a request. So I'm constantly sending these requests, and I'm constantly getting back a response. And that is how you navigate the web. So when I first talked to you in Mod 1, right before your feelings, I said something about the GET request response lifecycle. Right? So does that make more sense to you? About like everything I'm doing on the internet essentially is some sort of request, response. Request, response. Yeah? Cool. So here, right, all I want to show you is in HTTP, right, because there's HTML, CSS, JavaScript. There's something called graphics, APIs, and DOM. You'll learn about that later. Right? In HTTP, there's only 4 things you can ever do with data, right? You should have learned this in Mod 1. What are the 4 things we can do with data? What is CRUD? Yes, sir.
Create, update, delete.
And delete, right? And then do you remember Mike Chang in your intro to SQL lecture where he mapped everything to these CRUD functionalities? Right? He's like, okay, great. Create is some sort of like insert into a table, right? And then read is just like the select star, and then update is what? Like update, right? And then delete is what? I think it's destroy. It's destroy, right? I could be wrong. My SQL is rusty. Same thing with the browser, right? We've all agreed that these are the only 4 things you can do with data, because I mean, it makes sense, right? I can't really do anything else with data, right? Besides make it, blast it, update it, or just like render it. So all the way on the bottom, you learn about cores later, authentication, caching, something called request methods. I keep saying request, and I keep saying something called get, and I introduced a concept called post. So here, we have all of these. The browser, as it stands right now in HTTP, what, 1.1? That's what we're on right now. Yeah, it's 2018. You ever like mess with something on 1.1? It's old. It's old. Either way, it only understands 2 things, right? Get and post. So post is what again? Just like a quick refresher. Just in your own words.
Search bar, plug it in.
Right. Whenever the user is sending these parameters over to the server, right? Whether it be like I'm trying to log in, I'm going to post my username and password. I'm going to send you my email and my password, and I want you to do something with that, right? I want to create a new user, sign up for GitHub, cool. I'm going to send you my name, my email address, like the password that I want, and my social security number, credit card, right? Okay, probably lost you there. Don't send those things, right? That's the post request. Whenever you send information in any sort of form, you're posting. So here we have a get, which is what? I'll just help you out here. Okay. It is a verb, yes. They are verbs, and it's very important that you say that. It retrieves data, right? Cool. Then you have something called post, right? Which what? Sends data to the server, right? So if I can get data and I can send data to create something, what else am I missing in terms of my CRUD functionality? The U and the D, right? The update and the delete. Here we have something called delete. Wild guess, probably delete something, some sort of resource. Yeah? Here's like the one real tricky thing. We have something called put and patch, and I'll explain the difference, right? So put is sort of like I'm putting in a new row in my database, but more like I'm like replacing a row in my database. So like if I have 10 users, right, and user 9, I want to like update them in some way, but I want to update all of their information, right? Their username, their email, and their password. I want to update the entire row in that database. I'd be putting essentially what is known as like a new row in lieu of that, in replacement of that. That's still considered like an update to my database, right? I'm not adding user 11. I'm sort of updating user 9, but with like all new data. I'm putting new data in to an old column. Does that make sense? Right? What if I had like a pipe though, and like just like an interesting transition. I had like a pipe, right? And there's like a small little leak on there. Do I replace the whole pipe, or do I just slap some flex tape on that bad boy?
Flex tape.
I'm slapping some flex tape, right? What would you consider that? Like a partial update, right? I'm like patching something. right? Like in my user database, right? I have name, username, email, I don't know, likes cake, Boolean, obviously, true, default. What if for one day I found out that I'm just like super allergic to eggs and milk and it's like terrible, so I have to change this cake to false? Do I need to replace the whole row? I'm just gonna patch it up real quick. I'm just gonna change that Boolean, just that one little piece of data, and I'm gonna patch it. Would you consider that some sort of creation, update, delete, or a read? An update, right? So update has two forms, put and patch. If you were to pick one by default, which one would you pick? Which one would happen more often? Patch, right? So if you see patch, just think update, right? If you see put, just be like, I learned about it, and it's kind of cool, not gonna use it very often. I know what it is, but patch is kind of the way to go, right? And then delete is destroy, or destroy is delete, however you wanna think about it. That's like all the CRUD functionality. In my 4 HTTP verbs, and they're very important to like note of. Cool? Questions on the 4 CRUD functionalities and how they map to HTTP verbs? Sure.
No, I think it's like maybe too far.
I will let you know.
Okay, so I read that technically there really are only 2 methods, that is post and get, and then the other ones is like some kind of hacking them.
Absolutely. The internet is broken. So I will get to it in part 2 of the lecture, right, which is like this afternoon. But remember when I tell you that the browser only understands get and post, right? So I have to kind of hack my way to do the delete and like the patch, right? And we'll show you what that means later. I'm going to deploy a bunch of labs to you, and then we'll continue that on this afternoon. But in the meantime, I do want to talk about rack for a few minutes, and then I will let you go. Cool? I know you're getting antsy, and I'm kind of boring. My old school jokes are not great. So, HTTP verbs, right? So let's start talking about dynamic and static. Can everyone see this? All right, like you should like kind of read through this. There's all these like great student-facing readmes that Andrew and I wrote like a dissertation on. So if you ever like miss out on the lecture, or if you want to follow along the lecture, the readme should be like pretty good. This is like a better map of what the internet looks like right now. Cool? Sweet. So, all right. First thing you should do whenever you get a new file or like a new application is you should go through what that application is doing so you can understand how everything's connected. Because unless you understand how everything connects and what code is running what, it's probably not a good idea to update it, right? Probably don't want to like mess with it unless you understand how it works. You guys want to like break open a watch and be like, yeah, no, this is great. But like trying to put it back together is a little tough. So first thing you want to do is look at this, right? app.rb. All I'm doing is requiring pry, right? And I'm pulling in something called song. Cool, let's take a look at song. We don't need this anymore. Boop. Boop. All right, look familiar? Do I have to explain any of this? It's mod 1 stuff, right? Baby talk, right? Cool. Oh, I have song, right? Just gives me access to this song class. Cool. I have a class called app that I just built, and it's doing something called call with environment. And I'll explain what that is here in a little bit. I'm making a request, and I'm making like a response with something called rack namespace request. Who remembers what this is? I think I like walked in on your lecture during inheritance. No? It's a different class? Okay. Just made, man, must be smoking crack. Either way, rack with a namespace request. So I put these comments up here. Some sort of module, probably like a class of request that's in there. Yeah? Look familiar? About how that structure looks like? Cool. So we don't need this, right? And like when it initializes, it starts with some sort of environment hash that I'm passing in. All right, don't worry about environment hash right now. It's really not that important. I have a to-do here that says, let's make some songs. If you did the rack homework, this should all make sense. If not, I'm going to try my best to explain it and then execute it. So if the request.path, right, is equal to or matches, this is like the terminology for match, something called /songs, Then my song list is just I'm going to map through all the songs, and I'm going to make an li tag with that song.title. Cool? So what I'm going to do is I'm going to write a response. Remember, I'm making a GET request to my server, right? And I want to send back some sort of response. That response is going to be this bomb song list. It's going to be wrapped in this unordered list, and each one of them are, again, remember, they're LIs, right? So they're LIs wrapped in here. And that's it. I'm just going to write the response. Cool? Otherwise, if it's artists, I'm just going to say some artist list, or I'm going to write a div that says not found. I'm almost done. Give it to you. And then some sort of like random image, right? It's a cool image. When you write your Ruby methods, you def method name, and then you must end, right? So this response.finish is essentially like the end, right? Right here, I open it up. I say, hey, here's this new request. Right, here's the response. I'm going to write a response, and then I'm going to finish the response. Are there any questions on what's happening here conceptually? Because I'm going to like walk you through and show you what it's doing. Cool? So if you did like the pre-work, then you'll see here. Ooh, nice. Then I can just do something called rack up. And that's just going to start up my server. All right? Rails and Sinatra are built on something called rack. And what rack allows you to do is partition a small part of your computer to be its own internal running server so that you can build something in development. And what that means is I'm not pushing it to the internet. It doesn't exist anywhere outside my local machine, my actual computer. So it's fun to just play around with, see everything work, and then when you're ready, all right, we will teach you how to deploy it to like the internets. Cool? But for right now, I'm just going to start the server. Rackup is going to look for my environment, and it's going to feed it into my app. I'll show you exactly where it's doing that. In config.ru, it's running app.new. That's all it's doing. Cool? So right here, what did I get? I got my Ruby version, all right? Some sort of server with a method of start. This is the process ID. And we'll talk about that probably in a couple of days, not right now. Long and short of it is this is like the ID that my computer understands that this server is running on. So if I ever want to stop this server, I have to stop the process ID of 4106. Does that make sense? Cool. And this is the port. We talked about port 80 being the default for like the World Wide Web. This is the port that I'm going to be running my rack server on. So here, I can just go to, right? Remember, this is my local host, right? This is my local machine, right? This rack server. And I'm on port what? 9292? So if I go here, what should I expect to see? Oh, look at this meme over here. Why? Well, let's go back to app, right? Did my path, my resource match songs or artists? No. Else, give me this div with like this old image dude, right? Who's like, like you ever see the rest of this thing? He's like, all right, cool. So what if I went to artists? What would I get? I would just get this artist list, right? Because that's all I told it to write, this H1 artist list. Whoa, easy, man, easy, right? So if I were to go to songs, it's going to iterate through all my songs, right? But we need some songs first, so let's make some. Song.new. Cool. What's like a name of a song? Okay, great. Hit Me Baby One More Time. Pretty good. Classic. Anything else? What are you guys listening to right now?
Sorry, Justin Bieber.
Oh, was that loud? Sorry. No, what a great song. Actually, the music video is pretty good.
That's great.
Yeah. Anything else?
Oh my god.
Veto that one, right? Anything else? Okay. Do you You guys want to see something cool? Just so I can spice this up. If you hold Command Control Spacebar, you can do this. Oh snap! You can put up emojis in there. Damn! All right, cool, great, awesome. So how do I hit this route? What do I need to do? Bomb song list, right? Why is this not here? Because I need to restart my server. Right? After I update something, I have to restart my server, which is pretty annoying. Very quickly, Sinatra will show you something called Shotgun, which will auto-load your code for you every time it saves, so you don't have to deal with this. Cool? There it is. There it is. Oh, the emoji didn't come out. It comes out in Rails and in Sinatra. Cool. What would you describe this as? The last thing I want to leave you with before we leave is this dynamic or is this static? And what does that mean? Okay, who says static? Who says dynamic? Okay, great. All the dynamic people are correct. So I'll explain very quickly the difference, and I'll show you the code. So if something is dynamic, it means that it's rendering based on some sort of database request. That means that it's not hard-coded, and that each individual page can be done through like interpolation. So here, if I wanted to put song list items, I can easily copy this, right? Write it inside this response. Well, I have to interpolate it, right, with Ruby. And now I will have all my songs in my artist as well, right? So I can just do like something like a p tag and just put artist, right? And then I can like close the p tag. Oops, almost wrote PHP. It's trash. All right, and then I could do something like this, right? Oops, I need the double quotes. You know what I mean? String interpolation only with the double quotes. No? Okay. All right, then I can do like song list items here. And just like that, I've rendered all my songs under my artist as well, right? Here's what the static version would look like. Okay, instead of this, instead of interpolating, because all I have to do is what? Add another like good song, right? Like, you know what? Just drop Jenny in there. Jenny. Right? Now I've added Jenny to my song list, right? Just like that. If I wanted to do it statically, I'd have to do this. All right? I'd have to put hit me baby one more time. Yeah, trash. All right? Sorry. Hashtag. Not sorry. Right? And then, right? Then Jenny, because I'm going to skip over that other one. Right? This right here would be static. I'm hard coding the values every single time. So if I wanted to do like some sort of list, right? I would have like artist.new and it would be like, you know, R. Kelly. And then I can interpolate R. Kelly song list. I could do song.all. Right? And then I can do, what, .find with R. Kelly, something like that. So I can only pull in R. Kelly songs. And then I would do a string interpolation of R. Kelly songs here. That would be dynamic. Static, again, is I'm hard-coding the values. Right? So static is hard-coded. The values never change unless I go in and change them individually. Dynamic means it's rendering based on data. So if I just change the data, it's going to render everywhere that I call that data. So it's a little bit more dynamic, right? So in the same way that if I were to go to, right, Google. Cool. Who thinks Google has hard-coded every single search parameter ever? Like if I put Reddit, it's going, great. If user puts in Reddit, these are the 647 million results it's going to send back. And it's all hard-coded in a database somewhere. No, it's probably running some algorithm that based on this user input will return from like a database source. Does that make sense? So static and dynamic. Are there any questions on the difference between the two? All right, great. That's all I got for you today. Cool. All right, so what I'm going to do now is